Let's talk about testing. Okay, so it's the middle of conference season. Every year during conference season, Apple releases its newest operating systems, and as an Apple fanboy, I'm always like, oh, I want to upgrade, but oh, my slides have to work. So I usually hold out. But this year they announced the new iPad Pro, which is coming out this week. And it made me think, like, maybe this is the year, and maybe OS 9's ready to do full talk-in. So this entire talk is going to be done in OS 9. And let's kick it off. This is a little bit retro. That's cool. Starting up, I'm going to open up my presentation here in AppleWorks. The whole talk's done in AppleWorks. Just got to find the weird play button. Okay, cool. This talk is how to stop hating your tests. My name is Justin. I play Searls on the internet, and I work at the very best software agency in the world, Testable. So when I say hate, why do I say hate? Well, a lot of teams start off in this experimentation mode where they move really quickly, they move fast and break things, and they're constantly pivoting. And so having a bunch of tests would just slow them down, but eventually they get to a point where they have something successful and they want to make sure that each time they push their code, they don't break stuff. So it's helpful to have some tests. So those tests tend to be pretty realistic and integrated, but they serve a useful purpose. But if that's the only type of test they write, after a couple years, the app gets really, really big, and those tests are really slow, and then it really slows down the feedback loop of knowing whether or not things are working. And that leads to just this final stage in the life cycle of test hatred, which is like, man, I just long for the old days where we could just push code and know really quickly whether it was safe and then move on. And I see this repeat over and over again on different teams, and so I'm starting to think that an ounce of prevention might be worth a pound of cure. Because once you get to the point of you have like a really big, slow test suite, there's not a lot you can do. Some people will just say, like, well, you know, like, our test approach is not working, and others will reply, well, then apparently you're just not doing it hard enough. And I've never really believed that the work harder comrade approach to solving problems is effective, especially in the face of problems that keep seeming to come up over and over again. So instead, I always am looking for ways to improve our tools and improve our workflow. Another thing you see on these sorts of teams at this moment is like somebody will say, we just got to buckle down. Testing is job one. Let's focus on this. But from the perspective of the people paying for you guys to build software, it's not job one. At best, it's job number 2, because from the perspective of the people paying our salaries, shipping new code, shipping features and changes, that's always going to be job 1. And if you buckle down for a few months to focus on testing, that's just going to cause friction with that impedance mismatch. Now, I'm talking about prevention here, but if you're not a greenfield app, if you've got a lot of legacy code, that's not a problem. There's actually this weird trick to starting fresh with testing. That's right, you're going to find out what the weird trick is. Basically, you just move the directory into a new directory, and then you create another directory, and then you have 2 directories, some with good tests and then all of your old crappy tests. And you can port them over as you make changes, and then eventually you'll be able to turn off the old crappy tests on your continuous integration. Sadly, though, in preparing this talk, I'm the bad kind of expert. I've got too much experience with testing. I got 7 years of navel-gazing, lots of open source projects. I've been on many, many teams at this point, and I've gotten in a lot of highfalutin philosophical Twitter arguments about the right way to do stuff. And my advice has become this toxic hellbrew of cynicism and risk aversion. And I don't want to be here and demotivate you and tell you everything that's wrong with your tests. So instead, my goal is to take all of that and distill it down into just its useful component parts. We're going to talk about 3 different categories of stuff in this distillation. One is test structure, like physically, what do our tests look like? How are they laid out? How are they structured? Another is isolation, because what we isolate our test from, what we control for, is a great way to communicate the concept of our test, and it does a lot to determine the value we can hope to get out of each test. And third is feedback. Is it enjoyable to work with our tests? Do they make us happy or sad? Are they fast? Are they slow? And things that impact our relationship, our working relationship with our tests experientially. Again, this is all just like, prevention. This is us trying to find a way to head off at the pass a lot of common pitfalls that teams fall into. At this point, because keeping with the Apple theme, my brother dug up this old Apple II diskette of Family Feud. So we ripped off their artwork. It turns out it's really hard to make art in AppleWorks on Mac OS 9. But this is going to be our game board for the day. Now, if I were to point at the screen and say, show me potato salad, it'll show an X. But unfortunately, I didn't have 100 people to survey. I just surveyed myself 100 times, so I already know all the answers. In round one, we're going to do test structure. And I'm going to say, show me too big to fail. Let's talk about big functions and objects. Have you ever noticed that people who are really into test-driven development and testing seem to really hate big objects and functions like more than normal people? I mean, granted, everyone agrees that big objects are hard to deal with, but an interesting thing here, it's counterintuitive, most people don't realize, is that tests actually make big objects even harder to deal with than not having tests for them at all. Some of this relationship between big objects and tests are straightforward. For example, big objects have a lot of dependencies, and big tests, as a result, have lots of tests set up. Big objects have lots of side effects in addition to whatever they return, and therefore tests have to have numerous verifications. But the tricky bit is that big objects have many logical branches based on arguments in state, which means that we have many test cases to write to cover everything, and this is where things really fly off the rails. So let's take a look at some code. Unfortunately, it was this point of this, when I was preparing the slide, I realized OS 9 doesn't have any sort of Unix or terminal, so we had to go dig up a separate one. So this is a Unix terminal here. Let's run a test. Checking out, open up some Vim. And I'm going to write a test of a validation method in a timesheet application. And it validates whether or not somebody has to enter in notes. And whether or not you have to enter in notes into your timesheet depends on whether you're an admin, whether it's an invoice week, whether you have time, whether the project requires notes. There's 4 Booleans that go into it. And I wrote the first test, and then I start writing out all these other contexts for all those other test cases. What I fell victim to here is called the rule of product. It's a real thing from combinatorics and math. You know it's a real thing because it's got a Wikipedia page. You can go check it out. But to summarize it, for this method with 4 arguments, you take, for each of those arguments, all of the possible values, you multiply them together, and that's the total number of potential test cases that you may have to write. This is actually the simplest case because they're all Boolean, so it's just 2 to the 4th, so there's an upper bound of 16 test cases I may have to write in this circumstance. And when you're used to lots of big objects, big functions, you might just say to yourself, well, I'll just add one more little argument. What harm could that do but to double the number of test cases that I have to write? So it's actually the case that having tests of big objects and functions makes writing them even harder. And that's a surprising thing to teams who are used to having lots of big code everywhere. They want to get serious about testing, and they realize that testing is only slowing them down. So my recommendation is stop the bleeding. Don't keep on adding to your big objects. In general, new objects I write have 1 public method and at most 3 dependencies, which freaks out a lot of people who are used to seeing a lot of code. They'll say oh my gosh, well, they'll have too many small things. There's going to be well-organized and carefully named and comprehensible small things everywhere. This is untenable. And it's there's a professionalism sort of thing here where people feel no, I'm a serious programmer because I have to reason about all this ridiculous complexity, and what you're saying is programming on easy mode. And they're right. It is easy. It's really easy to work with a lot of small things, and I recommend everyone do it. I have a much better time. Next thing I want to talk about is people hate their tests because they go off script. So code can do anything. Our programs should naturally be really creative and unique and solve all sorts of interesting problems. But every test can really only do 3 things. They all follow exactly the same script. Every test ever will set stuff up, invoke a thing, and then verify its behavior. Some people call these the 3 phases: arrange, act, and assert. A more English natural language way to say that is given, when, and then. And when I'm writing a test, I always am very careful to consistently call out all 3 of those phases. So if I'm writing an XUnit test here, I'll use just significant new lines to separate arrange from my 1-line act from my assertion. Every single time, those are the only new lines in my XUnit tests. If I'm doing a BDD-style test like RSpec, it gives me different API hooks that kind of hint at the same thing. So I can use let to set up new values, for instance. So I set up those values with let. And then I can use before to indicate this is my action that I'm taking. And then those 2 assertions, I could keep them in one it, or I could split them up into separate its, so that each little line indicates what phase of the test I'm in. I also try to minimize each phase to just 1 line per action as a guard against test-scoped complexity leaking into my tests. The late, great Jim Weirich wrote a Ruby gem called RSpec Given. That is like a given when then conscious API. I loved it. He ported it to Minitest as well, and then later on I ported it to Jasmine, and somebody else ported it over to Mocha for JavaScript testing. And what's cool about given is you see the same RSpec test, all those lets become givens. It's straightforward. That before becomes a when. And it comes with this really, really terse but very effective assertion API. You just say then, and you give it a comparison. You can say and give it another comparison. It's going to print out, it's going to actually interpret that code as new Ruby and give you really great error messages. And I've noticed that tests that are conscious of these three phases are easier to read. They point out potentially superfluous code if it doesn't fit one of those phases well. And it can highlight certain test design smells. For instance, if you have a lot of given steps, there's probably too much setup. There's too many dependencies or too complex of arguments. If you need more than one when step, it usually means that the API isn't very user-friendly. It should be really straightforward to invoke any bit of behavior in our systems. And if you have multiple then steps, then maybe the code's doing too much or returning too complex of a type. Let's move on and talk about hard-to-read code. So test code is code. A lot of people like to say, hey, it's serious, it's code. But it's also untested code, which means it should be minimized and treated with extreme prejudice. And I found that in particular, having a lot of logic in our test code confuses the story of what's being tested. It makes it less clear about, I can't just look at some test code that has a whole bunch of loops and ifs and elses and draw a lot of conclusions about the behavior of the thing it's testing. I have to read that and take it on its own and then read the code. It slows me way down. Also, test scoped logic, apart from being hard to read, if there are any errors in there, they're very easy to miss because it could just be green for no reason and I can't catch it because there's no test of my test. Sometimes people come up to me and say, hey, I could really dry up this test, though, by generating multiple test cases in a loop. For instance, if you're doing the Roman numeral kata like this, you could just lop off those additional 13 assertions and then drive out of a hash, dynamic methods. And so here you could use define method to create a new test method, for instance, and then have this assertion driven dynamically. And that works. There's nothing technically wrong with that. But what I've noticed is that when you have loops and branches in your test as a response to test pain, the first place that we should always look whenever we experience test pain is there something with the production code that's causing this? Maybe it's better to improve that than just make the test look a little cleaner. Because this was that person's production code. You can see these ifs and elses all have that same data embedded in them, and they're there as very error-prone logic. Instead, it makes a lot more sense to attack that problem, maybe introduce the same sort of data structure into the production code, and then we can just delete that 15 lines of if-else garbage and replace it with an admittedly dense implementation that also passes the tests. That way, instead of needing a whole bunch of test suites for all those other cases above, they're just additional data in some data structure. It's much simpler this way. Sandy Metz, who's a great author, has a thing called the squint test for reasoning about certain conclusions about big blocks of code when she's trying to understand a big code base. And I do the same sort of thing when I'm reading somebody's tests. Particularly in a BDD style, I want to see all the indentation under a thing pointing out clearly this is one thing under test. And each sub-indentation, the first nestled indentation should be each method under test, ideally in the same order they're defined, so I can just scan through. And I use the context keyword when I'm using rspec to point out these are the two logical branches. And that nesting is helpful because it's a mirror of the actual cyclomatic complexity of the function being tested. Additionally, arrange, act, and assert, if you apply them consistently, you'll be able to see them at a glance, which is super helpful when you're reading. And even if you're using XUnit style testing where it's flatter, you should still be able to skim through and see real punchy arrange, act, and assert so it's easy to read. Next up, I want to talk about magic. Some people really hate seeing a lot of magic stuff happen in their tests, and some test suites, frankly, don't have enough of it. Really, all software is obviously a balancing act, and testing libraries are no different. They vary dramatically in how expressive they are. Some have a small API, which usually means that they're not as expressive. Others have a large API where you have a whole lot of features, but you have to learn them all. Minitest is an example of a Ruby test framework that is very, very minimal. As the name implies. Everything is just a class. There's a couple methods you can override, like setup and teardown. Each test is a method. Everyone understands methods and classes. Assert equal are pretty simple assertions. Ryan's a funny guy, so he has some in there like I suck and my tests are order dependent, which fixes the order. rspec, meanwhile, is a very large API. There's describe and context and subject and let. And then there's before, after, around with 3 different levels of scoping. There's it and specify. There's object should have. And then there's expect to be and all those matchers. There's shared example groups and tagging. Lots of advanced features. Jim Wyrick, with the given stuff, he tried to have it both ways, and I think he did a pretty good job. We have given and when and then. We have and invariant. It's a real small actual API, but it's just as expressive as most tests need, and thanks to natural assertions, there's not really a custom assertions API necessary. But because given's built on top of Minitest or RSpec or Jasmine, you also actually do have all the complexity on top, so there's still a lot to know. And not to say there's a right or wrong level of expressiveness in testing APIs, but smaller testing APIs are easier to learn, and that's useful for getting started, but they risk redundant or complex test code in various situations. Bigger test APIs, they yield very terse tests, but they look like magic to outsiders, which can be really frustrating to novices. Last thing that really bugs people about test structure is accidental creativity, because consistency is golden in testing. Let's take a look at that test that we looked at earlier. We set up 3 different things with let, but I can't tell at a glance which one is the thing under test. So in my test, I always name the thing under test subject, no matter what. And I always name whatever I get back from it result or results. That way, when I'm scanning a big test, I can really clearly see this is the thing under test, and this is the thing that I'm asserting on. Inconsistency, when everything is consistent, can convey a lot of important meaning. So if I've got several tests, and I'm just looking at them, I say, oh, wait, test C is a little weird. That must imply that there's something special about object or type C or function C. Let's look into that and figure it out. But I only get that benefit if things are generally consistent. If every single test is a special snowflake, I have to bring that same level of scrutiny and close reading to every single test, which really slows me down. So on the whole, I would much rather be maintaining dozens of mediocre but consistently applied tests rather than just a handful of very brilliant and awesome but super creative and inconsistent tests. Also, readers have this silly habit of assuming that all of our code has meaning, but there's a lot of meaninglessness stuff happening just to make our test work. And when we can point out that meaningless stuff, it really helps readers out. So in general, my rule of thumb is I try to make unimportant test code look obviously unimportant to the reader. An example of this is like I'm creating a new author here, and he looks very realistic with John Smith and a real phone number and an email address. But in this particular function, it didn't matter what the name or the email was, so I just changed them to something silly. And then I set up the assertion, and now the contract between the data and the behavior is much, much more clear. No one's going to read that assuming that he has to have a valid phone number now. So test data should both be minimal, but also minimally meaningful. That way you're not going to throw your reader looking down a rabbit hole that doesn't ultimately matter. All right, so good job. We did it. We talked through round 1, test structure. Let's move on to round 2, talking about test isolation. The first thing I want to talk about here are unfocused test suites. When most teams try to define success on their teams, they simply ask the Boolean question, is it tested? Yes. And if it is, they feel pretty good about themselves. But I think just as important of a question is the purpose of the test readily apparent? Does its test suite provide consistency? And the answer there is almost always no. And this causes some consternation when I raise it, because when I say be consistent, people often raise, well, I have a lot of different kinds of tests. I have to test for all sorts of different situations. How can they possibly all be consistent inside of this one test suite? And that's a good point. And so I've started in the last several years actually creating separate test suites throughout my application for each type of test that I want, each one with very clear conventions and rules of the road of how to write the test, and sometimes even separate like test helpers and configuration to exemplify those norms. I wrote a whole talk just about this called Breaking Up with Your Test Suite. That's a short URL there. The testing pyramid is a visualization that Agile people tend to use to show how integrated tests are, with more integrated tests being at the top and less integrated tests being at the bottom. And when I look at most teams, they'll have one big suite and their tests are all over the place. They'll have some tests that call through to other units, other tests that fake out their dependent relationships with other units, some tests that maybe hit a database but fake out third-party APIs, some tests that'll call through to those APIs but fake out the user interface. And when I come here, I'm just like, every single test has to be read very, very closely and carefully. Instead, when I'm starting any new thing, I always encourage my teams to start with just 2 test suites, each approaching the logical extremes, because it makes it really obvious what should be faked and what shouldn't. At the top half, we make as integrated a test suite as we can possibly manage, and at the lower half, we make as isolated a test suite as we possibly can manage. The test at the bottom, we just make sure every single file listing does its individual job, and that test that glues everything together makes sure that when it's plugged together, nothing blows up. It's really straightforward and really, I think, self-explanatory to work with. Now, it might the need might arise to have some sort of like middle tier level of testing to cover edge cases. For example, I was on an Ember.js team, and we had component tests. But we all agreed up front to establish some norms, like we're going to fake all the APIs, we're not going to use test doubles, we're going to trigger logical actions, not UI events, and we're going to verify app state and not HTML templates. And we had to police ourselves to make sure that we didn't stray from this, because it would be too easy to start becoming inconsistent. Another thing I want to talk about is I think another thing bums people out about their tests are too realistic of tests. It's worth asking, like, how realistic should our tests be in order to be valuable? And I think a lot of people have an impulse that more realism is always better because you're more sure that things are working. If you take, as an example, somebody who's really proud of this web test, where it opens a browser, talks to a real server, talks to a real database, I might poke holes at them. I'll say, hey, well, does it talk to your production DNS? And they'll say, well, no, of course not. And I'll say, well, does it talk to your CDN and test all your cache and validation strategies? And they'll say, well, no, not really. And so while they think that what they're doing is maximally realistic, they have defined a border. It's just implicit of what's being tested and what's being controlled. And the problem with that being implicit as opposed to explicit is that somebody on the team is completely right to ask, whenever something blows up, oh my gosh, why didn't we write a test for that? And this creates a sort of a trap on teams like this, where they'll write a test, something will blow up in production, and then their team lead or whoever will come back, and they'll all have a come to Jesus meeting and say, why did this happen? And they'll say, never again. Then they'll go back to the drawing board and increase the realism in all their tests. The reason this is a problem is that realistic tests are much slower. They take more time to write, to change, to debug. They require more cognitive load. You have to have the entire system in your head to understand what's going on. And they fail for more reasons because there's so many moving parts. So what I find is that setting really clear boundaries between what's being tested and what we're controlling for helps to increase focus and helps to increase teams' ability to communicate the purpose of their tests. So the same team with clear boundaries would write some tests. Something would blow up in production because tests aren't a panacea, stuff still blows up in production, but they'd be able to stand with a backbone and say, look, we didn't write a test for that because we all agreed up front it would be too expensive to test with that level of realism. And besides, we didn't anticipate this thing happening, and it's really hard to automate stuff with an automated test that you can't predict. And finally, sure, maybe this is a problem that we can write a targeted test for, maybe against the Facebook API or something, but we don't necessarily need to make that leak into all of our other tests throughout our whole test suite. Aside from the fact that they're slower, realistic tests aren't some kind of, a virtue in and of themselves. Less integrated tests are great too. They offer tighter design feedback because we're closer to the code. And as a result, it's much easier to understand and respond to failure messages when they blow up. Realistic tests lead right into talking about redundant test code coverage. What is redundant coverage? Well, suppose that you have a lot of tests, and maybe you have tests of the browser, tests of your views, tests of controllers, tests, all those call through to the same model. And then you got some other models that are related to that model that indirectly test that model as well. And you might think of this as being like, wow, that's very thorough. Now, assume that you're a test-driven development team. So the developer goes in and writes a failing test and then makes that test pass. Test first. They push off to continuous integration, and they expect to see everything pass, but it doesn't. All of those tests above will fail, as well as the related model tests, because the developer only anticipated that local change and didn't really think everything else is only incidentally depending on this behavior. And so then they spend the rest of the week just cleaning stuff up. So indeed, it was a thorough test suite, but it was redundant as well. And redundant coverage can really kill team morale. The problem with it is it might be fine when everyone's running locally and stuff, and the app is still small, but as the app gets bigger and there's more interaction between your features, this can really slow down a team's productivity. How do you detect redundant coverage? The same way you detect any coverage. You can run a code coverage report. Now, when most people run a code coverage report, their eyeballs zoom straight into this column. They're looking for targets of things that they don't have tests for. But I actually like this column in this case. It shows how many hits per line. So that thing at the top when I run my test gets invoked 256 times. That means if I change that method, I'm probably going to break a whole lot of tests. Now, to prevent this, one approach is to identify a clear set of layers that you're going to test through and exclude others. So in this instance, maybe it makes sense to have these browser tests because they tell us everything's all plugged together. But the view tests and the controller tests are probably pretty redundant, and maybe this team is fine with just browser and model tests. A totally different strategy, you could try your hand at outside-in test-driven development, where you do write tests for all those different layers, but you isolate the thing under test from the things it depends on. Some people call this London School test-driven development, or mockist, or GOOS. How I practice it, I've come to call it discovery testing, because we're discovering our dependencies as we go. I recently did like a 3.5-hour free screencast series that leads by example on this and shows at least how I practice it. That's up on our blog at this short URL. And it would only be fair, I just brought up test doubles if I talked about how a lot of people, what they hate most about their test suite is over-mocking or careless mocking. So a test double, if you're not familiar with the term, just means it's a catch-all term for a stand-in in a test. Any real thing we replace with a fake thing in a test is a test double. It might be a hand-rolled fake object, or a stub, or a mock, or a spy. What's funny is I come from a company called Test Double. We built a company named Test Double, and we maintain several Test Double libraries. So when I go to conferences and talk about testing, people often assume, well, I guess that means you're pro-mocking. You love mock objects and stuff. And I wish that were as straightforward, but it's not quite that obvious. In fact, the way that we use mocks is extremely unpopular and nuanced. So in this instance, if I have like some subject I'm going to write a test for, maybe I'm imagining it's going to have these 3 dependencies. I'll write the first test and fake all those out before I've ever created them, and then I'll listen carefully while I'm writing that test for any awkwardness in those proposed API contracts between the subject and its dependencies. And if anything's weird, I'll fix it in that moment before I've invested the time in those dependencies. It's a way to kind of use my test as a design sounding board. Now, is that how most people use mock objects? Absolutely not. Most people simply have this cool mocking library, and when the going gets tough trying to write an otherwise realistic test of their code, maybe some of the dependencies are easy to use, but some of them cause setup pain, or some of them make it hard to assert stuff. And so they simply use the mocking library as this cudgel to shut up the dependencies that are causing pain, and now you have this test that's really in a confused state. I mean, they were using mocks there to treat a symptom of test pain, but not the root cause, which is probably a screwy contract between the subject and its dependencies. From the perspective of the people reading that test in the future, like what's being tested, what's real, what's fake, what's the value of this test, all those questions become very unclear. And lastly, it makes me really sad because it gives test doubles a bad name, and my company's named Test Double, and I got to protect my brand. So if you see somebody abuse a test double on your project, please say something and use the hashtag #MockYoMocks to call it out, and I will promote it. Last thing I want to talk about is just a little deviation, talk about app frameworks. So frameworks, the reason that they rise to prominence is that they provide repeatable solutions to common problems. Most commonly, how do I get my app to talk to X thing? The integration-related concerns. So if we imagine the code in the center of this diagram as being plain old decoupled, plain old objects and functions, and the code at the periphery being the stuff that's framework coupled, like us extending framework types or interacting with framework code, you can imagine like the framework is a shell providing us access to all sorts of cool integrations that enable our app to do useful stuff. And different applications have different degrees of framework tangling. Some have a healthy amount of domain stuff in the middle. Some systems I see, every single line of code is coupled somehow to the framework. And other ones have very, very thin layers of what they might call just libraries providing this kind of support, and tons of domain objects in the middle. But the dilemma raised by frameworks is that, like I said, they focus on integration problems. That means when they hand you a test helper, those test helpers also tend to assume the same level of integration. And because people who use application frameworks will often look to the framework to provide answers to almost every question, it leads developers to only write integration tests because they assume that they have to use those test helpers to write a real test. Of course, that's not true, because if some code doesn't rely on a framework at all, why should it test? You can always just write a plain function to test a plain function. Yeah, you can still have a test suite that goes through and calls through all that framework code and exercises your system when it's glued together, but you can have a second suite that's just as divorced from your application framework as your code is. So that was a little bit about test isolation. Good job. We're 2/3 of the way through our journey. Let's go on to round 3, talking about test feedback. Show me useless messages. We're going to talk a little bit about error messages in tests, and oh shoot, I broke the build. So let's talk about how to respond to this. I'm going to go pull down the code, and we'll work on it together. So let's run this test. This is a real test from a real Ruby gem I maintain. Okay, let's look at the error message. Failed assertion, no message given. That's not a great error message. This doesn't really cue me in. I see it's line 25. So my workflow to resolve this issue, see the failure, read the test, find line 25, put out a print statement or start a debugger. Then I can change the code, hopefully see it pass. And by now, because 20 minutes have elapsed, I'm ready to take a break. And that's my reaction every single time any test fails. So that's really inefficient. So we often pride ourselves in having very fast test suites, but if you have really bad error messages, the friction and waste caused by that is more than enough to offset whatever speediness you have. Let's look at a test with a better error message. So this is an RSpec given test. You can see the assertion is just username equals that string. I'm going to run just that test, and when we do, we're going to get a much nicer error message. Zooming in on it, you can see it prints out the expected, the equals. It actually is interpreting and invoking that whole little block. So you can see that evaluates to false. The thing on the left evaluates to that string, which was wrong. And it actually goes and keeps calling it as long as it's callable. So the thing underneath the highlighted area is the printout of the active record model, and I can read all the properties on it. It's so helpful of an error message that very often when I'm using given, my test failure workflow is I see the failure, I change the code, and then I earn a big juicy promotion because I'm so much better at my job now. So what I implore you to do is when you're judging an assertion API, don't just look at how fancy and fun the API is to use. Really grade it based on how good of error messages does it give you. Next up, I want to talk about feedback loops. 480 is a significant number because it's the number of minutes in an 8-hour workday. And we're going to talk about how little microsecond changes in our productivity loops can affect how much stuff we can hope to get done in a day. Let's say we take 15 seconds to make a change, and 5 seconds to run a test, and then 10 seconds to respond and figure out what we're going to do next. That's a 30-second feedback loop. So in an 8-hour day, that means we'd have an upper bound, a maximum of 960 useful thoughts in that day. Now, most people have non-code related activities that they're responsible for at work, and then we also suffer the context switching between those and our code. And in a 60-second feedback loop, this would allow for 2 hours of non-code activity at 480 actions per day, which let's use as a reasonable baseline. Now, our application is successful, and our interactions between features mean that each test now, it doesn't take 5 seconds to run a test, it takes 30 seconds to run a test. So we've gone from 60 to 85 seconds. So we're already down from 480 to 338 actions per day, but that non-code, that 2 hours of non-code time in our day, that doesn't care how fast our tests are, and so we have to amortize that over all of those loops. So that's up to 21, now we're at 91 seconds. And we've lost fully a third of the number of feedback loops we can hope to get through in a day. Now, pretend that we're not very careful about our error messages, just like I wasn't in that gem. And instead of taking 10 seconds, it takes us 60 seconds to figure out what to do after each loop to interpret the test results. So now we're up to 155 seconds per feedback loop, which yields only 185 actions that we can take each day. Now, a lot of teams have a lot of really slow integration tests. Pretend you drew the short straw, and it's your job on this iteration to update all of the integration tests that the team just broke, and running an individual integration test takes a full 4 minutes. So now we're looking at a 422-second feedback loop, which yields only 68 actions that we can take in a day. And if you've ever run a 4-minute test, you know how easy it is to tab away, look at Reddit, look at Twitter, look at email, and before you know it, oh shit, 3 minutes have elapsed since the test finished. This happens over and over again, and effectively that means that our feedback loop is now 11 minutes, and this only allows for 43 actions per day. And your brain starts to rot after a couple of months like this, but the way that teams get to this point is little tiny bits of slowness over time, and so we just acclimate to these really, really non-productive environments. In fact, 43 is a lot less than 480. And if you pause for a second, you'll realize that we just found it, the 10x developer. This is, I say that to indicate a few seconds here and there really start to add up, and they can really creep up on you, seeing teams go from very productive to not productive at all. So personally, I profile my productivity by measuring and optimizing my own feedback loops. I'll pull out a stopwatch and see where my time is going every day. And if it's still too slow, if there's just some impediment or the system is just too big and monolithic, I'll implement features outside of that application to find my own happy place and iterate quickly, and then integrate later. Obviously, integrating later isn't ideal, but it's much better than just waiting all day. Next up, I want to talk about painful data, because controlling test data is really hard. And how much control each of our tests have over their data varies based on our strategy. For example, you can create every new model in line in each test, which is very verbose but gives you a lot of control. Or you could use like a fixture strategy where you have a handful of models that are kind of a starting point to every test. You can maintain a data dump, like a SQL data dump that you just like prime everything with before you start each test suite. And there's also these things called self-priming tests, so you euphemistically have no control over your test data at all. Rather, like if you want to test an account, your test has to first create an account, go do all the stuff that you want to do, and then, if possible, deactivate or delete that account at the end. And you don't have to pick just one strategy or one means of setting up test data. If we look back at the testing pyramid, maybe inline test data is great for just individual models because you got a lot of control. But for integration tests like controller tests or something, fixtures are great because then you can just get a user really quickly. You don't have to creatively have a whole bunch of different tests all creating their own user. I like to use data dumps for smoke tests that are making sure everything's plugged together so that not every single test has this 2 or 3 minute data setup tax. And then if you're testing against staging or production, you probably shouldn't have direct database access. So you probably have to write something that's more like a self-priming kind of, create the things that you're about to put under test. And in slow test suites, I've really noticed that data setup is usually the biggest offender, the biggest reason why each individual test is slow. Citation needed. I don't have any proof of that, but it seems truthy. What I do in my own practice is when I have some really slow tests, I'll profile them and then very aggressively target in on how to optimize the test data approach, which is a tertiary concern of building an application, but can be front and center like the biggest cause for productivity drain and is totally worth figuring out. Talking more about productivity, let's discuss superlinear build slowdown. What the heck do I mean by that? Well, our intuition about how long our test build should take tends to betray us, because if we have one test and that test takes 5 seconds, then we assume that 25 of them are going to take 25 times as long and 50 of them are going to take 50 times as long. And I think the reason is that if I say that a test takes 5 seconds, your brain just thought that's 5 seconds in test code. But in reality, it also has to run app code, right? That's the thing being tested. It also spends some time in setup and teardown. In fact, it spends most of its time in those two things. So a 5-second test might spend 2 seconds actually exercising the application, and 2 seconds setting up and tearing down data, and only 1 second actually in test code. So if you imagine us writing 5 of these big integration tests, maybe the app gets bigger, so the app gets slower, and the setup and teardown is concerned with more test data, so that gets a little slower too. And now this first test that we didn't actually change, it's identical, went from taking 5 seconds of wall time to run, and it now takes, 7? And even in the beginning, you'll see a slight deviation from your expectation that the build should grow linearly as you add tests. Now, imagine taking it from 5 tests to 25 tests. Maybe the time spent in app code goes from 3 to 4 seconds. That's not a huge change. And the time spent in setup and teardown goes up to 6 seconds. And now we're looking at 11 seconds per test. And here you see this deviation really start to increase. And teams are often surprised, like in the midlife cycle of their app, like, wow, like our build's a little slower than I thought. That kind of stinks. Our feedback's not great. But they're not, it's not cause for alarm quite yet. But if you just double the number of tests again, it's not shocking to imagine it going from 4 to 7 seconds of time in app code and going up to 10 seconds in setup and teardown. Usually there's big spikes, like a new feature will be lazily written and the test data will get drastically more complex for all the different tests. So now we're looking at 18 seconds per test, and this is where things really fly off the rails. See, like we had to zoom out. It's like now 900 seconds for the whole build. Thing that really throws people off, because we don't tend to think in terms of like geometric curves and productivity, is that first 25 tests, like at the point where we were at 25, we had deviated 150 seconds or 2.5 minutes from our expectation, from what our intuition told us the test should take. And the second half picked up an additional 500 seconds, even though it's both just 25 tests. Very often I'll hear from a team and say, like, my tests are a little bit slow, and then 3 months later, it'll be like, oh my god, my build takes 9 hours, what can I do? The answer is if you've got a 9-hour test build, it's really hard to put the genie back in that bottle. But from a preventative perspective, we should all be avoiding the urge to create a new integration test for each and every feature as if by rote. Instead, I try to just maintain a handful of smoke tests and exercise and snake through as many of the features as possible in as few as tests as I literally need. Also, early on, teams, I think, do great by themselves to cap or set a budget for how long they're willing for their build to take. And if it's 5 minutes or 10 minutes, they say, like, once it starts approaching 5 minutes, we need to either start deleting tests, start making our tests faster, or start optimizing our application to get faster. Because we need to make sure that we have a healthy, productive sense that when we push code up, we can know really quickly whether or not we just broke something. We don't have to wait till tomorrow. Last but not least, this is one of my favorite topics, I'm going to talk about false negatives. So what does it mean when a build fails? Well, it means that the code is broken, is what most people would respond. Nope, not really, because the follow-up question is, when the build fails, what file needs to change to fix the build? I think the reaction is, well, usually we have to update a test to fix it. Oh, so that means that a test was broken, not the code. And this is a good introduction to the topic of true versus false negatives. A true negative, when you see a build break, red means broken. And the response is you can fix it by fixing the code. And this is what managers think when they think about your build, right? They think that the purpose of the test suite is to prevent bugs from reaching production, and that whenever the build fails, that's what just happened. A bug stopped from getting into production. Now, a false negative, red means unfinished, because there was a test and we forgot to update it. And so the response is to fix the test. Now, true negatives, they reinforce the value of our test suite. They remind us of why our tests are there in the first place. Now, the sad thing is that they are also depressingly rare. And I can count on one hand the number of true negative build failures that I've seen in the last few months. That's unfortunate. False negatives, however, they really can quickly, you don't even need a lot of them, to erode the team's confidence in its tests. And they're why CI tends to bum people out. They'll see a build failure and then they'll, oh shoot, I forgot to update a test. The top causes of false negatives are, having a lot of redundant coverage, so people not anticipating certain tests to break when they make an incidental change over in this other corner of the system. And slow tests, because if the build's too slow to run locally before you push each time, you're going to have to wait until the build breaks and then the whole team is looking at it, i.e. having lots of integration tests. So one thing I encourage people to do, especially if this is a new concept to you, is track whether each build failure is a true or false negative, and then keep track of how long it took to build each thing. And you can use that data to justify where you invest your time in making broad-based improvements to your test suite. So congratulations, you just sat through 3 rounds of what little test advice I have to offer. If this talk bummed you out a little bit because there was a lot of problems in it, just remember that no matter how much you hate your tests, I probably hate AppleWorks even more. This is a challenging slide deck to produce. I mentioned earlier, I come from an agency called Test Double. We are senior software developer consultants. So if you're working at a company and you guys are looking for senior software developers and having trouble hiring them, we are great people to pair with. Hire us instead, and we'll join your team and work alongside you. If that interests you, come grab me after. I'll be in the hallway. If your goal in life is to help other software developers improve the state of things in the software world, we'd love to talk to you about joining our team as well. So feel free to come up, grab me, tweet me, whatever, and I'd love to talk to you. Most importantly, thank you so much for sharing your precious time with me. I really appreciate it.